Hey Defenders, welcome back. In this video, I want to show you guys how we can understand Wazuh decoders so that we can have the ability to create our own custom decoders that will allow us to ingest any type of log that we are looking to ingest. So some key features, Wazuh comes pre-bundled with a ton of decoders and rules already configured, but we may have some one-off use cases where the pre-built decoders and rules do not match on the type of logs that we're looking to ingest. But thankfully, Wazuh gives us the ability to create our own custom decoders. Using custom decoders, we can instruct Wazuh how it should read and parse through the raw log that it receives. And it's super flexible. It's powered by a few regex libraries that we can take advantage of to build really complex matches that will fit any use case, which is really awesome. And this will ultimately allow us to ingest any type of log into Wazuh. We can then create rules to match on certain patterns within our log files that we're receiving, and then we'll be able to view those logs within Kibana. So the steps for this video, I'm going to walk through an actual real-life scenario of configuring our pfSense firewall to send syslog events to our Wazuh manager. We're going to view the issue of, okay, we're getting the logs to the manager, but we're not actually able to view them within Kibana or anything because Wazuh doesn't have the ability to decode them. So we'll look at what the root kind of issue is. We're then going to walk through a simple decoder example, and then we're going to create a custom decoder and rule for the pfSense syslog events that we are collecting. And this video is sponsored by Sock Fortress. I am going to follow along with their blog posts throughout this video. So huge shout out to Sock Fortress and go check them out. And all right, so first I'm on my pfSense firewall. Let's configure this guy to send syslog output to our Wazuh manager. So I'm going to pop into status and I'm going to select system logs here. And I'm going to go into settings. And I'm going to make sure my log message format is set to syslog, so that looks good. I'm going to scroll down, and here I'm going to select the checkbox for enable remote logging. I'm going to scroll down a little more, and I'm going to go ahead and say log everything. The source address I'll just leave at the default. However, now I need to point to my remote log server. So I'm going to point to my Wazuh manager, which is sitting on this internal IP address and is listening for syslog connections on port 514. So that's the only change I'll need to do on the pfSense side. So that's pretty simple. So I'll go ahead and save that. And now on the manager, on our Wazuh manager, let's go ahead and enable the remote syslog ingestion that we want our Wazuh manager to be able to do. So I'm going to open up the var osec etsy osec.conf. I do have another video that I'll link in the top right in the description below that goes into a little more detail for configuring syslog input on the managers themselves. So check that out if you haven't already. And then I'm going to paste my remote block in here. So I'm telling Wazuh, hey, let's listen for a syslog connection on port 514. Your protocol is going to be UDP. I'm going to allow this IP range here. This is just anything within my private network here to be able to send logs to our Wazuh manager. So that looks good. So I'm going to save that, and I'm going to go ahead and restart our Wazuh manager. And now with pfSense configured to be sending these logs, which should be, yep, that looks good. So once this guy comes back, we should now start to see logs. We should now start to see logs hitting our Wazuh manager, and log all JSON tags here set to yes, so that we can actually see these logs come through even though they're not going to match on any rule sets, right? So we'll be able to tell our archives.json file to view logs that the Wazuh manager received, but it doesn't have any rules but it doesn't have any decoders or rules built for that specific log. So Wazuh doesn't know what to do with it. And that in turn, and it doesn't write it to its alerts.json file, which is the file that gets stored into Elasticsearch, right? So this is a good way to, when you're troubleshooting or whenever you want to pick up, okay, what is the raw log that's actually being sent to the Wazuh manager, go ahead and set these guys to yes, and then tail the archives.json, which we'll do in a sec, to actually capture the raw log. A little disclaimer though, once you do have that raw log, make sure you set these guys back to no, because it does consume a lot of disk space. So just make sure you set that to no once you're done. So let's go ahead and tail our var osec log archives.json. And here we can see our syslog events starting to come through. So I'll go ahead and stop this. Here we can see these are coming from my pfSense router and firewall here. You see we're not able to match on any decoders or anything. And then we see some of the syslog output here. So looks like we get like a timestamp that we see here. We see the name, the host name of the router. Some other metadata, looks like if it matches a firewall rule or not, what the action was. So was the traffic allowed or denied? In this case, it was a pass. We then see the protocol. We then have some IPv6 data, and yeah, so cool. So we're now receiving, so we know that our syslog from pfSense to our Wazuh manager is working, right? So those logs are getting there, but now we need to build decoders and rules so that our manager can actually match on them, and then store them into Elasticsearch. So I mentioned this video was sponsored by Sock Fortress, who has a blog post I'm going to be following along with throughout this video. So if you guys want to follow along, I'll link to the blog post in the description below that you guys can check out as well. So let's first understand how to build our decoder. And in this example here, I'm not going to use our syslog logs just yet. Let's just use a goofy log. And the beauty about the decoders is we can build decoders off of anything. You know, regex matching is crazy powerful and really allows us to be flexible on what we want to match on. So in this example, we're just going to take this goofy log of this medium. Sock Fortress is an awesome company. Check them out at sockfortress.co. So let's go ahead and see what this looks like as of now. So let's go ahead and run our Wazuh log test. Another little useful kind of trick, another useful tip when you're building your own decoders and rules, this is an awesome binary to take advantage of, because this tells you how the Wazuh manager is actually parsing and ingesting your logs. So let's go ahead and run that, and you'll see here we'll have the option to now type our log entry. So I'm going to go ahead and copy this guy and paste it here. And here you can see, so we completed our pre-decoding, so there were no issues there, so that's good. However, now we couldn't decode on anything. There's no decoder match. So no decoder match, of course, means we're not going to be able to compare it against any rule set. So Wazuh at this time has no idea how to actually parse through the received log so that we can move it on to the next phase of comparing it against a rule set. So let's go ahead and first create our parent decoder. And this parent decoder will allow us to pre-match, like we see here, on any regex match that we want to incorporate. So in this example, I know, and when writing decoders for your logs, it's good to kind of understand what fields may be unique, what fields stay static, so that you can build your decoder to accurately match on the format and fields that you are actually getting with your raw log, right? So I recommend, before even attempting to build a decoder out, is really understanding your log. Okay, what are the various fields within this log? What has the ability to be dynamic? What is static and is a part of every log that I ingest, regardless of the content, right? So really understanding your log is kind of step one and what you want to get a good grasp on prior to actually attempting to write your decoder. So in this case, what we're going to do is just pre-match on medium, because we know that this medium string here is going to be at the start of the log. And this is going to be static for every log that we receive from this medium test log, right? So this is a good match, and we could do a pre-match on anything within this log here. If I wanted to pre-match on Sock Fortress, I could do that as well by replacing our medium with Sock Fortress. But let's go ahead and copy this decoder, and I'm going to open up the decoders. I'm going to open up the local decoder.xml file, and I'm going to scroll down, and I'm just going to paste that here. So again, what we're doing is we're giving our decoder a unique name. So we're just calling it medium, and we're telling this decoder, hey, I want you to match, if you see the string medium with this colon here at the beginning of the log. And that's represented, and that's specified with this caret symbol here. So let's go ahead and save and restart the manager. And if I copy this rule again, let's now run our log test and see what the results look like this time. So that's restarted. I'll go ahead and run our log test again, paste that in there. And here you can see, oh, look at this. We've now matched on our new parent decoder, right? So our pre-match of medium is now working correctly, right? So Wazuh is saying, okay, I saw the string here, medium colon, at the start of the log entry. So I know now. So I know the decoder I want to use is going to be this medium decoder, and that's what we see here. So let's now start to build out to where we can strip out maybe the company and the website as separate fields that we can use to build a rule on. So I'm going to go back into my local decoder.xml. And here we're going to use a child decoder. So if we scroll down here, we'll see our syntax block for our child decoder. So I'll go ahead and copy and paste this guy here. And here we're giving our decoder name a unique name, so medium_child. We cannot have the same decoder name as our parent, right? So this needs to be a unique name. It can be whatever you want, but you just need to make sure it's unique. We are saying, hey, what is your parent? Well, your parent is going to be our medium decoder that we just wrote here. Right, so very similar to Wazuh's child and parent rules, right? So Wazuh, when it matches on this parent decoder, and it'll match by seeing the string of medium with a colon at the beginning of the log entry, it will then say, okay, so now I have this child who's a parent of the medium decoder. Let me now compare the log against that and see if we have a match. And then in our regex field, we specify what we want to match on. So after our parent is matched, so meaning that after medium, this medium string has been observed. Let me go ahead and paste this here so we can kind of walk through it. So this medium has already been taken care of by our parent decoder that we see here. So now we start to build our regex. So we say, okay, after medium, we're going to start, and this /s here means a space. And if you go to Wazuh's website, which this is linked in the blog post that we have here, you'll see the expressions that you can use to match on various characters, right? So a /w is any character A through Z, uppercase or lowercase, any numbers, any dashes, the @ symbol, and underscore characters. A /D would say, hey, I want to only match on a number. I know that this is going to be a number. The number may be unique every time, but I know it's going to be a character of a 0 through 9. Our /S that we see here will match on a space. And so because our raw log, so we have medium, which we've already matched on, but we're now starting right after that. And right after that, we have a space, right, that I'm highlighting here. So we first do our /s because we know there's going to be a space here, which in regex expressions is how we identify a space. So we first do our space, and then we use our parenthesis operator. And what this tells Wazuh to do is okay, whatever is within this parenthesis, I want you to assign it a field of whatever I've set in my order. And in this case, we're saying company, because I know whatever value is here that we receive from our log, that's going to be our company, whether it be SOC Fortress, whether it be OpenSecure, whether it be YouTube, right? That field is going to be dynamic, and I want Wazuh to set it to a field name of company, and we'll be able to then build a rule off of the contents within that field name. So that's what our parenthesis operator does. It takes the regex match that we have here, and this regex match here specifies anything. So the /+ is basically regex wildcard. So what Wazuh is going to do is say, okay, whatever I match on up into the is statement that I have here, that's what I'm going to set as the company field. So if we didn't have the rest of this block here, what Wazuh would put into the company field would be the whole block, because this regex match here will match on anything until the end of the file. But because we're telling Wazuh with the parentheses operator, we're saying, I want you to take the match. When Wazuh sees the string is, it says, okay, I know my wildcard regex match is complete, right? And then Wazuh will take the value that is stripped out within the parentheses here and assign them to the company field. And same with the website. So as we scroll down here, we know the website can also be a dynamic entry, right? This could be opensecure.co, this could be socfortress.co. So again, we use our parentheses operator that we have here because we're telling Wazuh, hey, let's go ahead and assign this to the website field. And because I know the website's going to have https:// I know that's going to be static. So then we're telling our regex match, hey, anything after that, let's go ahead and match on. And then because that's the last entry in the log, right? Once our website is complete, that's all that log entry has. I know our regex match is now complete. So let's go ahead and save this off and restart, and let's go ahead and we'll run the log test again and see what our results look like now. So if we go ahead and paste that in there, you'll notice our company and our website are now being stripped out. So our child decoder is working correctly. The parenthesis operator that we're using to match on the company field and the website field is working correctly. And since these regex matches are wildcards up into a certain point, right now, let's go ahead and change the company from SOC Fortress to OpenSecure and change the website to the OpenSecure website. So I'm going to go ahead and scroll down and copy this block here. So now we see our log changing, right? So our pre-match is still going to be the same because, again, understanding your logs and what fields are static is essential for creating accurate decoders. But we see now SOC Fortress is replaced by OpenSecure, and then the website is also replaced, which, because those are our regex wildcard matches, we'll now see when we copy and paste, in our log test here, we'll now see the company and the website change to what we've ingested with our log, right? So here we have OpenSecure and OpenSecure, and we're not creating a separate decoder for that, right? That is, these are dynamic and changing on the fly for us as Wazuh is able to parse through the actual logs. So good. So our decoder is now complete, but that's only half the battle. We now need to create a rule that will match on what we want the rule to match on. And in this case, we have fields to match on. So we have company, and then we have website. So we can tell our rule, hey, I want you to look at the contents of either of these fields and I want you to match on something in particular. So let's go ahead and do that. So let's go ahead and match on when we have the raw log of Medium. SOC4tress is an awesome company. Check them out at soc4tress.co. So we're now going to navigate into our etsy rules, localrules.xml. I'm going to go ahead and scroll down to the bottom here, and I'm going to copy the block that we have in the blog post here. And let's go ahead and step through it a little bit. So you can see we're using our decoded as, and we're setting that to the parent decoder name that we use so that Wazuh knows, okay, when I decode this log, and I use the decoder of Medium to do so, I know now, hey, this is a rule that could potentially match on this decoded log. So that's what we're saying there. We're then stripping out the field of company. Now this could be either company, this could be, in this case, this could be either company or website, because those are the two fields we're telling Wazuh to strip out and assign. So in our rule here, we're saying, hey, I want the field name of company to be equal to SOC4tress. And if it is, then I'm going to say, go check out the value that Wazuh stripped out for the company field and for the website field. So if I go ahead and save that, let's go ahead and restart. I'll go ahead and copy this guy so we're ready to test when Wazuh is restarted. Go ahead and clear that out, and let's run our log test, and I'll paste that. And here you can see our decoding worked, and now we have our phase 3 has completed as well, matching against our rule that we just created, right? So that was 100,021. And you can see our description is populated with our dynamic field. So go check out SOC4tress at, and then the website as well. So another cool little tip you can use when building rules is you can populate your descriptions with dynamic fields that you receive from the actual alert log itself, which is pretty cool. Because now that our rule ID, right, we're only matching on if the company field is SOC4tress. So if I took my open secure log here, right, so now our company field is going to be open secure and not SOC4tress. So the rule that we just created is not going to trigger because the field name of company is open secure. Here you can see now we don't have our phase 3 that we got in the previous run when we ran it with the SOC4tress. So again, if we paste in our SOC4tress alert, we see the phase 3 completed and matching on our rule. And if we paste in our open secure, right, we're not triggering our rule. So let's go ahead and change that. So what I can do is then within the rule file here, if I just copy this block, paste that, I'll go ahead and I'll just change the group to open secure if I can spell the own name right. Let me increment this guy. We're still decoding as Medium. We're still using that decoder, but our company, instead of SOC4tress, we're going to say, let's go ahead and match on open secure. So if I save, restart, and let's go ahead and run our log test again, and I'll paste in open secure is an awesome company, blah, blah, blah. Now you see our new rule is triggering, right? So now we built a custom decoder and custom rules to match on logs that we can receive to Wazuh that aren't supported by default, right? So that's looking good. So let's go ahead and configure a custom decoder and rule to match on our pfSense syslog events, right? So if we look at our raw log here, pfSense does not do a very pretty job of specifying any static fields. So you're kind of left guessing at some of the kind of important contents, I guess, of this log. So the one things I can obviously see is the name of the router that's receiving these logs, so that's good. I guess some type of maybe function within pfSense, this filter log. There's some metadata here. This looks like maybe a virtual interface name. This match, I'm assuming, is if it matched a firewall rule or not. This pass, I'm assuming, is the action. So did the firewall allow this traffic through or did it not? The direction, I'm assuming is identified with this out field here, meaning either outbound or inbound. You then have some metadata here, metadata. Looks like we then get the protocol. So here we see UDP, another metadata field. Not sure what these digits in specific are. Maybe they're interface stats or something like that. But then we see the source IP address, and then we see the destination IP address, and then we have some more metadata. Maybe this pertains to like how many bytes were transferred out during this connection. I'm not totally sure. So some logs that you'll look to ingest will be parsed out very nicely, and it'll be obvious what the various different values within these fields can be. But some, like in this example, it's a little more trivial to understand. But if we went ahead and copy and pasted this guy in our log test, you can see we don't have a decoder match. So let's go ahead and follow the same steps. So we're first going to build our parent decoder, and looking back at our log, every log that we receive from pfSense that is syslog starts with this numerical 1 here at the beginning of the log. Why it does that, I'm not really sure. And I don't know if this value could change to a 2, for example. And that's where we can take advantage of our different expressions to match on anything, right? So we can use our /d because I know it's going to be a character of a 0 through 9. And in this case, it's a 1. This may always be the same. This might change depending on the day or the week or the month or whatever. Not totally sure. But because we're not sure, we can use our /d regex expression to match on a character that's 0 through 9. So if this did change to a 2, for example, this wouldn't break. Our decoder wouldn't break because it's still a digit of a 0 through 9 that we specify here, right? And then we see a digit, a digit, a digit, a digit, right? Representing 2022. So we have /d for the 2, we have /d for the 0, we have /d for the 2, and then we have a /d for the 2, and then we use a dash. So with regex, you can either be explicit and give the actual character, or you could use an expression. So here I'm being explicit with the dash, but as we looked at, we know a dash is also represented with a /w. So instead of being specific and using a dash, I could technically use a /w, and our regex match would also match on that as well. So with the regex expressions that you can build, you have the flexibility to match really on anything. And there could be a few different ways that you could approach actually matching on the log, right? And then we step through. So we have our dash, that we then have a 0 and a 4 followed by another dash. So if we look back in our regex, we have our /d and our /d matching on the 0, matching on the 4, and then the dash, and then we have the number 2 followed by the number 2, and then we have this T13. So I just specified this guy here. Probably best practice though, this looks like it's a part of the timestamp, so this is probably going to change. So actually what we could do here is that T will probably always be the same, but I'll go ahead and do /d and /d because this 1 and this 3 looks like the time of day that it's happened. So this is going to change all the time, right? So we want to make sure our decoder is built to match on that. So we'll go ahead and say a /d saying that, hey, I know this is going to be a character of 0 through 9. And then we traverse through the rest of our log here all the way up until our 0, right? So this is going to be our parent pre-match here, right? So we know, hey, Wazuh, when you see a regex that matches what we've built here, this is going to be a pfSense firewall log, and we're giving it our decoder name as well, right? So let's go ahead and copy this guy. Let's go back into our decoders, and I'll go ahead and paste this guy here. I'll save, restart, and then let's go ahead and then run our log test and make sure our parent decoder is working appropriately. And let's run our log test. And here you can see we post our raw login, and we get our parent decoder as matching. So that looks good. So let's scroll down a little bit and let's now configure our child decoder. So again, we kind of talked about the fields that we wanted to strip out that represented these guys, right? So we have the router, which appears to be the whatever is in this field here, firewall action, which we had pass, the direction of outbound or inbound, I'm assuming is what the other option could look like. The protocol, so here we have UDP, the source IP address that we have here, and then the destination IP. So let's go ahead and build a child decoder that will strip all of these various fields out, and then using our parenthesis operator, right, we'll say, hey, I'm going to take the value that's in this field and assign it to the order that I have below so that I can then build a rule off of it. So copy that, we'll go back into our decoder here. And I'll paste this guy here. And here we're saying, again, let me kind of expand this out a little bit. And here we're giving our decoder name of something unique. This is our child decoder, right? So I'm just calling it pfSense _ router. Our parent is going to be our pfSense decoder. And now, okay, after the parent is matched, so, and again, that parent match being that long timestamp that we were looking at, what will the rest of my log look like? And how do I want to strip and name the fields out? So one tip as well is this order is sequential to the parenthesis operators that you have above. So my first parenthesis operator, so this guy pertains to the router. Second parenthesis operator, so the regex match that is matched within this block here, but within these parentheses here, will pertain to my firewall action. The regex match that matches within these parentheses here will be my direction. So these do have to follow the same order. So whatever is stripped out first will get whatever is first within your order block here. Whatever is stripped out second will pertain to the second item here, and so on and so forth. So that's one thing to consider as well. And let's go ahead and paste that log. Let's kind of follow through how we're doing the matching. So our pre-match, right, what we have here is taking care of everything up until here. So this is our pre-match. So our child rule, because we are specifying it after the parent, this has already been matched on. So we're not needing to match on that. So then we say, okay, now I want you to do a wildcard regex match for our next string all the way up until filter log. And I want you to, because I'm using the parenthesis operator, give that the field name of router. So that is going to match on this block here. Right, so regex is going to match on all of that. It then says, oh, I see the filter log, which is not within my parenthesis operator. So that's not going to get assigned that router field as well. Right, we then match through. So we then have this string of numerical characters. We have -- which I'm specifying as literal. Again, this could be /w/w. String of characters, these 3 commas. So these logs that we get from pfSense are not the cleanest or most user-friendly, that's for sure. But we're then just regex matching on all of these different values that we could possibly have here until we get to the firewall action, where is either pass or drop. So I'm using my regex expression to match on 4 characters, A through Z, capital or lowercase, 0 through 9, whatever the case may be, because I know this can either be pass or drop. Both are 4 characters that the regex expression of /w would match on, because our lowercase p, for example, would fit within the valid character of a lowercase a through z. Our lowercase a would match, our lowercase s, and our lowercase s would also match. If this was, instead of pass, if it was drop, right, that also fits within the bounds of any character a through z. The d is a valid character, the r, and so on and so forth, right? So we're then using our print. So our regex match is going to be 4 characters that are valid with a /w, which the pass and drop would both match on. And we know they're going to be 4 characters, so that's why we specified that there. So if there were 5 characters, say this was like passes or something, that was 5 or 6 characters, that was 6 characters longer, this regex would not match on it because it would stop at 4. And Wazuh would see, oh, you're over the 4 characters, so I'm not going to match on this. And because that's within our parentheses here, that'll get we're then specifying that to the firewall action. And these can be named whatever you want. So you can be totally flexible with these names. You can customize them how you see fit. So that looks good. So let's go ahead and save that, and let's go ahead and restart our manager. While it's restarting, I'll get that log copied again. And now when we run our log test and paste it, we should now see our fields. We should now see our fields start to be stripped out. So let's go ahead and run our log test. And if I paste this in here, we now see our fields start to be stripped out, right? So we get our router stripped out, and here we see router local domain. We get our protocol stripped out. We get our firewall action, so we're matching on that pass. We're getting our destination IP and our source IP address as well. Right, so our child decoder is now matching on the various fields, right, that we see here. It's stripping those dynamic values out and assigning them to these fields, just as we stated here. So that's looking good. So lastly, now let's create a rule that, let's say, okay, let's log everything. Let's go ahead and write to Elastic and create a rule that matches on when the firewall action field is a pass. And in this example, we see the firewall action field contains the string pass. So this rule will match when we go ahead and implement it. So let's go ahead and copy this guy. Let's go back into our local rules.xml file. I'll go ahead and scroll down to the bottom, paste this guy here. I'll just give it a group name of pfSense and syslog. Rule ID we've incremented are decoded as. We're now using our pfSense decoder and not our medium decoder as we had above. So we want to make sure Wazuh will compare this rule when the pfSense decoder has matched. And we're then specifying, hey, when you see the field firewall action equals pass, that's when I want this alert to trigger. And we're going to say, we're going to do a description of traffic from the dynamic field that we stripped out, source IP and destination IP has passed. So let's go ahead and save that, and let's go ahead and restart, and I'll get my, let me get the log within my buffer here. If we run our log test and paste that guy in, now we see our new rule is triggering. So our rule ID 100,023, traffic from, then we see our rule description be populated with the stripped out source IP to the stripped out destination IP. And then we know that because we're matching on the pass field, it has passed. So our Wazuh manager is now able to match on this particular log. And because our Wazuh manager is now able to match on this, right, this is now getting written to the alerts.json file, which file B is then picking up and sending to Elastic. So now if we go into Kibana, now we can actually view all of our rules, right? So here you can see I'm getting some other syslog events, and I have traffic going out to this destination IP address, and it has also passed. It's also using a protocol of UDP, and now we get the full log here. So we went from not being able to, so we went from our Wazuh manager not being able to understand our syslog events at all, right? We created our decoder, we then created our custom rules to be able to match on this, and now we can visualize them within Kibana and build dashboards and take advantage of our other Wazuh features that we've been covering throughout the life cycle of this channel. So I think that wraps it up for today's video. Again, go ahead and check out the Sock Fortress blog post, and huge shout out to them for sponsoring this video. And I appreciate you guys hanging out with me, and I will see you in the next one.